Hello. This is a short video on the binomial theorem and how the binomial coefficients can be found in Pascal's triangle. The binomial states that if n is a positive integer, then x plus y, quantity to the n, is equal to this expression. These are the coefficients n choose k. K is going to be an integer from 0 to n. This summation notation or sigma notation means we are going to be summing, so we're going to be using addition signs. And k is going to be starting out with a value of 0 in the first term, then a value of 1, 2, all the way up through n. Let's look at an example. Let's say n equals 4. We would like to find x plus y, quantity to the fourth. The coefficients are going to come from Pascal's triangle. Here's Pascal's triangle. The first row is here, the second row, third, I'm sorry, the top row is actually row 0, row 1, row 2, row 3, and here's row 4. The coefficients in row 4 are 1, 4, 6, 4, 1. These are precisely what we need to fill this, to expand this binomial to the fourth power. So we write down our coefficients, 1, 4, 6, 4, 1. Then the first term is going to be x to the n times y to the 0, which would be x to the fourth times y to the 0, but y to the 0 is 1. The powers on x are going to be decreasing, so it's going to be x to the fourth, x to the third, x to the second, x to the first, and finally x to the 0. In the meantime, the powers on y are increasing, y to the 0, y to the 1, y to the 2, up through y to the 4. So therefore, x plus y to the fourth is x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Now let's look at a more sophisticated example over at PurpleMath. Here I am at PurpleMath, and they're going to be doing a very complex example or lengthy example, 3x minus 2 to the 10th power. Their statement of the binomial theorem is similar to mine, but they're using a and b, where I used x and y. The 3x is going to be playing the role of a, or playing the role of x in my notation. Negative 2 is going to be playing the role of b. Now they do talk a little bit about the formula for the binomial coefficients, and this is a formula using factorial notation, but you can also pull the coefficients right off of Pascal's triangle. It is useful to note that there are two notations that are used, this parentheses notation and NCK, which is n choose k. In fact, I like the way the author of this website points out that on the TI calculator there is an NCR for n choose R button, and you put 10 and then that character or button on the calculator 7, and this will give you 120. Let's find out where 120 is in Pascal's triangle. Here we are at Pascal's triangle. 10 choose 7 is going to be in the 10th row. So we come down to the row that has 10 in it, and we start counting over, the first position being position 0, 1, 2, 3, 4, 5, 6, 7. And we see here that 120 is 10 choose 7. And that can be done on a graphing calculator. Here's a little bit more information on Pascal's triangle, which we have in other videos. Now let's see the details of this lengthy example. The first thing we do is we write down the coefficients. 10 choose 0, 10 choose 1, 10 choose 2, 10 choose 3, all the way up through 10 choose 10. Those are going to come from Pascal's triangle. In the first term, we have 3x to the 10th, In the second term, we have 3x to the 9th. In the third term, we have 3x to the 8th, 3x to the 7th, all the way down to 3x to the 10 minus 10, which is 3x to the 0. On the other hand, negative 2 starts out with a 0 exponent, and then it goes to negative 2 to the 1, negative 2 to the 2, negative 2 to the 3, negative 2 to the 4, and so on up through negative 2 to the 10th power. Now we're going to be multiplying this out, and boy howdy do you need a calculator. So let's see what they have here. 10 choose 0 from Pascal's triangle is 1. 3x quantity to the 10th is 3 to the 10th times x to the 10th. 3 to the 10th is 59,049, x to the 10th. Negative 2 to the 0 is 1. 10 choose 1 is 10. 3 to the 9th is 19,683. Negative 2 to the 1 is negative 2. In the next term, we have 3x to the 8th, and that gives us 6,561x to the 8th. Negative 2 squared is positive 4. Pause the video if you wish to look at the other examples. Notice that when we take negative 2 to an even power, it becomes a positive number. When we take negative 2 to an odd power, we get a negative number. So what's going to happen when we multiply this out is every other term is going to be negative. Right here is the answer. 59,049x to the 10th minus 393,660x to the 9th plus minus plus minus all the way down to the last term, which is 1,024. This web page has additional examples if you'd like to look at them. This is the PurpleMath website. Have a great day.